Hello everyone, and a very warm welcome to you, wherever you are in the world. I truly hope this video finds you in the best of health and spirits, surrounded by positivity and good energy. Before we dive into today's truly fascinating topic, I want to take a moment to just send out a little wish for you and your loved ones. May you always be blessed with strength, vitality, and wellness. It's a crazy world out there, and taking care of our health is the most important thing. So, thank you for choosing to spend some of your valuable time here with me today. Now, let's get into something that sounds like it's straight out of a science fiction movie, but I promise you, it's wonderfully, beautifully real. You see, the humble banana, that yellow fruit you probably have sitting in your kitchen right now, is radioactive. But before you panic and throw your entire fruit bowl out the window, let me be absolutely clear, it is only mildly, harmlessly radioactive. This isn't a danger. It's one of the most perfect and natural examples of the world around us, a world that is, in its very essence, subtly and constantly humming with a very low level of radiation. This isn't a story about mutants or superheroes. It's a story about fundamental physics, nature's building blocks, and a concept that can help us understand the radiation we encounter every single day without even knowing it. To really wrap our heads around this, we have to go small. Incredibly small. We have to talk about atoms. Everything you see, touch, and are made of the air we breathe, the screen you're looking at, your own body, is composed of atoms. Think of them as the ultimate Lego blocks of the universe. For a long time, people thought atoms were the smallest possible things, solid and indivisible little balls. But we now know that's not true. Each atom has a tiny core or a nucleus right at its center. This nucleus is like the sun in a miniature solar system. And whizzing around the sun are even smaller particles called electrons. Now, the nucleus itself is made up of two types of particles, protons and neutrons. Protons have a positive electrical charge, neutrons have no charge, and the electrons orbiting around have a negative charge. Normally, everything is balanced. The number of protons, positive, equals the number of electrons, negative, so the overall atom is neutral. The number of protons is what defines an element. 1 proton is hydrogen, 2 is helium, 6 is carbon, 8 is oxygen, and so on, all the way up the periodic table. Now, here's where it gets interesting for our banana story. The number of neutrons in the nucleus can vary for the same element. These different versions of the same element are called isotopes. Think of it like different models of the same car. A Toyota Corolla sedan and a Toyota Corolla hatchback are both Corollas, the same essential car, the same brand, but they have a slightly different configuration. Carbon, for example, usually has 6 protons and 6 neutrons. We call that carbon-12. But there's an isotope of carbon that has 6 protons and 8 neutrons. That's carbon-14. It's still carbon, it behaves almost identically in chemical reactions, but it's a bit heavier and it's unstable. This instability is the key to everything. A nucleus can be unstable for a few reasons. Maybe it has too many neutrons, or too many protons, or just too much energy for its own good. It's like a wobbly top spinning on a table. It can't stay like that forever. It wants to find a stable, comfortable configuration. This process of an unstable nucleus trying to become stable is called radioactive decay. The wobbly, unstable isotope, often called a radionuclide, spontaneously transforms itself by getting rid of some extra energy or particles. It does this by emitting radiation. Now, the word radiation has been villainized by pop culture, but it's really just a general term for energy or particles traveling through space. When a nucleus decays, it can spit out different types of radiation to achieve stability. The 3 most common types you might have heard of are alpha particles, beta particles, and gamma rays. An alpha particle is basically a cluster of 2 protons and 2 neutrons. It's a helium nucleus shooting out. A beta particle is a high-speed electron, or its opposite, a positron, ejected from the nucleus. And gamma rays are not particles at all. They are pure energy, waves of light so powerful and so high frequency that our eyes can't see them, like super-powered X-rays. This emission of radiation is what we call radioactivity. And it's a completely natural, random process that happens on its own schedule for each unstable atom. So, what does all this nuclear physics have to do with a banana? Well, bananas are rich in potassium. Potassium is an essential mineral that our bodies absolutely need to function properly. It helps our nerves fire, our muscles contract, including that all-important heart muscle, and it regulates fluids in our bodies. A single medium-sized banana contains about 450 milligrams of potassium. That's a good chunk of our recommended daily intake. Now, potassium is an element. On the periodic table, its symbol is K from its Latin name kalium, and it has 19 protons. This means every single atom of potassium, everywhere in the universe, has 19 protons. But not all potassium atoms have the same number of neutrons. Naturally occurring potassium is actually a mixture of isotopes. The vast majority of it, about 93%, is potassium, 19 protons plus 20 neutrons. There's a tiny bit, about 0.012% of potassium, 19 protons plus 21 neutrons. And the rest is potassium, 41. It's that tiny fraction, the potassium, 40, that is the star of our show. Potassium, 40 is unstable. It's a radioactive isotope. It's that wobbly top. Over time, an atom of potassium, 40 will decay. It has a 50-50 chance of decaying in one of 2 ways. About 89% of the time, it spits out a beta particle, that high-speed electron, and turns into the stable calcium, 40. The other 11% of the time, it captures one of its own orbiting electrons, which causes a proton to turn into a neutron, and it emits a gamma ray, turning into the stable argon, 40 gas. So, every time you eat a banana, you're ingesting a very small number of these unstable potassium, 40 atoms. And inside your body, they are continuously, gently, and harmlessly decaying. They are emitting beta particles and gamma rays from inside you. Right now, as you watch this, you are mildly radioactive yourself because of the potassium and other natural elements in your body. This isn't something new. It's been happening for as long as life has existed. Because this is such a well-known phenomenon, scientists even have a cute name for it. They call it the banana equivalent dose, or BED. It's not a formal, official unit like you'd use in a laboratory, but it's a really helpful tool for popular science to put very small amounts of radiation into perspective. 1 banana equivalent dose is the extra dose of radiation you get from eating 1 single banana. We're talking about an incredibly, almost unimaginably small amount of radiation. To give you a number, it's about 0.1 microsieverts. A sievert is the unit scientists use to measure the biological effect of radiation. Now, that number, 0.1 microsieverts, means absolutely nothing to most of us without context. So, let's build that context. This is where it gets really fun. First, let's compare that banana to the radiation you're exposed to every single day, just from being alive on planet Earth. This is called background radiation. It comes from several sources. The sun bathes us in cosmic rays. The rocks and soil beneath our feet contain radioactive elements like uranium and thorium, which release a radioactive gas called radon. The very bricks, concrete, and stone used to build your house contain tiny, trace amounts of radioactive material. Even the air we breathe has a little bit of radioactivity, including the carbon, 14 we mentioned earlier, which we take in with every breath. All of this adds up. The average person on Earth is exposed to about 240 microsieverts of radiation from background sources every single month. That's the equivalent of eating 2,400 bananas in a month, or about 80 bananas a day. And remember, you're not actually eating 80 bananas a day. This is just a comparison to show how small the banana's contribution is. The radiation from the banana is utterly dwarfed by the natural background radiation that is an inescapable part of our environment. Let's scale it up even more. Think about taking a flight. When you fly in an airplane, you are higher up in the atmosphere. The atmosphere acts like a protective blanket that shields us from the full force of cosmic rays from space. Up at cruising altitude, that blanket is thinner, so you are exposed to more cosmic radiation. A typical cross-country flight in the United States might expose you to about 40 microsieverts of radiation. That's the equivalent of eating 400 bananas on that one flight. A long-haul international flight could be double that. If you are a frequent flyer or a pilot, your annual radiation exposure is significantly higher than that of someone who stays on the ground, but it's still considered a low dose. Now, let's talk about medical procedures. This is where the numbers get bigger, but it's important to remember that these procedures are done for a vital medical reason, and the benefits almost always far outweigh the extremely small increased risk from the radiation. A standard dental X-ray exposes you to about 5 microsieverts. That's 50 bananas. A chest X-ray is about 100 microsieverts or 1,000 bananas. A CT scan of your chest is a much more significant dose, around 7,000 microsieverts. That's the equivalent of 70,000 bananas. It sounds like a lot, and it is a larger dose, but it's a controlled, medically necessary dose used to save lives and diagnose serious conditions. It's a brilliant example of how we use our understanding of radiation for tremendous good. And this is a crucial point to understand. The dose makes the poison. This is a fundamental principle of toxicology that applies perfectly to radiation. Everything can be toxic in a high enough dose, even water or oxygen. Radiation is no different. The extremely low doses we are talking about from bananas, from background sources, from flying, and even from most medical X-rays are simply not a health concern. Your body has exquisite, built-in mechanisms to constantly repair the tiny amount of cellular damage that this low-level radiation might cause. It's only when the dose becomes very, very high that these repair mechanisms can be overwhelmed. The radiation from a banana is so low that it's lost in the noise of the natural background radiation that has been present for all of evolutionary history. Life evolved in a slightly radioactive world. In fact, you could try to eat enough bananas to actually get a dangerous dose of radiation, but it's physically impossible. To reach a radiation dose that would increase your risk of cancer in a measurable way, you would need to accumulate a dose of about 100,000 microsieverts. Remember, one banana is 0.1 microsieverts. So you would need to eat 1 million bananas all at once to get that dose. But there's a much bigger problem than the radiation. Potassium itself is toxic in very high doses. A condition called hyperkalemia, where you have too much potassium in your blood, can disrupt your heart rhythm and be fatal. The lethal dose of potassium is about 250 grams for an average adult. Since a banana has about 0.45 grams of potassium, you would only need to eat about 550 bananas very quickly to die from potassium poisoning, long before the radiation from the potassium 40 could ever possibly hurt you. So, the idea of bananas being dangerous because of their radioactivity is a complete myth. The fruit itself will kill you through sheer chemical toxicity far sooner than the minuscule radioactive component ever could. This natural radioactivity is also not unique to bananas. It's in many, many foods. Any food that is rich in potassium will have the same tiny amount of potassium, 40. Potatoes, avocados, lima beans, and even orange juice are all mildly radioactive for the exact same reason. Brazil nuts are another famous example, but for a different reason. They absorb barium from the soil, and along with it, they often absorb radium, which is another naturally occurring radioactive element. In fact, Brazil nuts can be thousands of times more radioactive than bananas. But again, the dose is still so low that it poses no health risk whatsoever. You would have to eat an absurd amount of Brazil nuts every day for years to even have a theoretical risk. The world is full of these naturally radioactive foods, and we've been eating them safely for millennia. So, the next time you peel and eat a banana, I hope you think about it a little differently. See it not as a scary radioactive object, but as a wonderful teaching tool. It's a perfect, snack-sized package that demonstrates the hidden, fascinating reality of our atomic world. It reminds us that we live in a universe where energy and transformation are happening at a subatomic level all around us and within us, all the time. It's a harmless, natural process that connects you directly to the core processes of the universe. That banana is a testament to the fact that a little knowledge can replace fear with understanding and wonder. It's a symbol of how science can help us contextualize the world, showing us that even something that sounds alarming, radioactive fruit, is, in reality, nothing to worry about and everything to marvel at. So enjoy your banana. It's a healthy, nutritious, and scientifically awesome choice. Thank you for watching, and once again, take care and be well.